Look at your hands. The exact arrangement of atoms holding them together, every freckle, every scar, every thought passing behind your eyes, is, according to mainstream cosmology, not unique. Somewhere out in the unbounded dark, roughly 10 to the 10 to the 29th meters from this room, another set of hands rests in another lap, reading these same words. Not a version of you, you. And beyond that copy, infinitely more. Tonight, we will travel outward through 4 nested layers of reality. From the edge of everything you can see, to regions where the laws of physics themselves may differ, to the branching corridors of quantum possibility, and finally, to a place so abstract it dissolves the boundary between mathematics and existence, and understand why the universe may not simply contain a copy of you, but may be constitutionally incapable of containing only one. Before we dive in, if you love exploring the nature of the cosmos and your place within it as much as we do, take a second to like the video or subscribe and tell me where you're listening from and what time it is. Now, let's begin. There is a number that cosmologists sometimes write down when they want to say something true and verifiable and almost completely impossible to hold in their mind. It is 10 to the power of 10 to the power of 29. Written as a number, it would require more digits than there are atoms in the observable universe just to express its length. And what this number represents, according to mainstream physics, is a distance, measured in meters, to a place in space where, if you were somehow able to travel there and look around, you would find a room identical to this one, a body identical to yours, a mind running through thoughts identical to the ones you are having right now. Not metaphorically, not approximately, atom for atom, configuration for configuration, thought for thought. This is not science fiction. It is not mysticism. It is the direct mathematical consequence of a universe that, according to our best evidence, is either infinite or so vastly larger than what we can see that the difference between infinite and merely incomprehensibly large becomes, for practical purposes, meaningless. And yet, we almost never talk about it. We learn the size of the observable universe, that sphere of space roughly 93 billion light-years across, bounded by the farthest light that has had time to reach us since the Big Bang. And we treat that number as though it were a description of everything that exists. We point to the cosmic microwave background, the oldest light in the universe, and we say, there it is, the edge, the wall, the end of the story. But the observable universe is not the universe. It is the universe we can see. It is the portion of an almost certainly far larger whole that happens to fall within our cosmic horizon. The sphere defined by the distance light can travel in the age of the universe. Beyond that horizon, space almost certainly continues. The galaxies do not stop. The atoms do not stop. The arrangements of matter and energy that give rise to planets and atmospheres and living things do not stop. What stops is only our ability to receive information from those regions. The universe continues without us, indifferent to our horizon. This distinction between the observable universe and the full universe is the seed of everything we are going to explore together. It is a distinction that most of us learn once and then quietly set aside, because the implications, followed honestly to their conclusion, are genuinely difficult to hold. But tonight, we are going to hold them. We are going to follow the argument all the way down. Here is where we need to begin, with what we actually know and what we have measured, and what those measurements quietly imply. The observable universe contains somewhere in the neighborhood of 2 trillion galaxies. That estimate, published in 2016 by Christopher Consolis and his team at the University of Nottingham, revised upward a figure that had been standard for decades. 2 trillion galaxies, each containing, on average, hundreds of billions of stars. The Milky Way alone holds somewhere between 100 billion and 400 billion stars, depending on how you count the dim, small ones toward the outer edges. Around those stars orbit planets. Around some of those planets orbit moons. On at least one of those planets, a species of upright walking, large-brained primates developed the capacity to ask questions about its own existence, and, over the course of several thousand years, built instruments sensitive enough to begin answering them. That species, us, has now mapped the cosmic microwave background with extraordinary precision. The data, gathered most recently by the European Space Agency's Planck satellite, which completed its primary mission in 2013 and published its final full data release in 2018, tells us something remarkable about the geometry of the universe. It tells us that space, on the largest observable scales, is flat. Not curved inward like the surface of a sphere. Not curved outward like the surface of a saddle. Flat to within the precision of our measurements, which is now better than 1%. And here is what flatness suggests, strongly and directly. Flat geometry is most naturally the geometry of infinite space, though a flat universe can still be finite if it has unusual topology, as some researchers have proposed. This requires a moment of care, because the logic is subtle. A positively curved universe, one that curves back on itself like the surface of a sphere, but in 3 dimensions, would be finite. Walk far enough in any direction, and you would return to your starting point, the way a traveler circling the globe eventually comes home. A negatively curved universe might also be finite, depending on its topology. But a flat universe, one where the angles of a triangle add up to exactly 180 degrees at every point, on every scale. The geometry is the geometry of infinite extent. There is no natural boundary. There is no place where flat space curves back to close itself off. The Planck data does not prove the universe is infinite. Flatness is consistent with a universe that is merely very large, far larger than our observable region, but technically finite. Some researchers, including Jean-Pierre Luminet at the Paris-Meudon Observatory, have proposed models in which space has a more exotic topology, like the 3-dimensional equivalent of a torus, that would be flat locally, but finite globally. These models have not been ruled out. They are, however, increasingly constrained by the data and the simplest interpretation of what we see. The default, the unadorned consequence of the numbers, is infinite space. Other researchers, including Max Tegmark at MIT and Anthony Aguirre at the University of California, Santa Cruz, have argued that infinite space is not merely the simplest interpretation, but is in fact the generic prediction of inflationary cosmology, the leading theoretical framework for understanding the universe's earliest moments. And if space is infinite, then what follows from that is not a possibility. It is a certainty. Take a moment to absorb that word, certainty. If space is infinite and matter is distributed throughout it according to the same physical laws that govern our observable region, and we have no evidence that the laws are different elsewhere, and every theoretical reason to expect they are the same, then every possible configuration of matter that can be assembled within a given volume of space will eventually be realized. Not might be realized. Not probably will be realized. Will be realized. An infinite number of times. The reason is combinatorics, the mathematics of arrangement. The number of distinct ways matter can be arranged inside a volume, the size of our observable universe is enormous, but it is not infinite. A universe the size of ours contains a finite number of particles. Each particle can occupy a finite number of energy states. The total number of distinct quantum configurations, every possible arrangement of every particle in a volume like ours, is a staggeringly large number, but it has a top. And any finite number, placed against the backdrop of infinite space, is eventually exhausted. Think of it this way. Imagine you are dealt a hand of cards from a shuffled deck. There are a finite number of possible hands. If you were dealt cards forever, by a truly random process, you would eventually see every possible hand, not just once, infinitely many times. The identical hand, your exact hand in the exact same order, would appear not once more, but infinitely more times. You cannot avoid it. Repetition is not a feature of infinite processes. It is their mathematical nature. The universe is that deck. You are that hand. This argument was developed in careful formal terms by Max Tegmark in a paper published in 2003 in the journal Scientific American, and in more technical form in a series of papers stretching back to the late 1990s. Tegmark calculated, using the number of possible quantum states available to a volume the size of our Hubble sphere, that an exact copy of our observable universe should exist at a distance of roughly 10 to the power of 10 to the power of 115 meters. A copy of you specifically, your exact brain configuration, your memories, your precise physical arrangement, should exist within 10 to the power of 10 to the power of 29 meters. These numbers are not meant to be visualized. They are meant to be understood as an argument. The argument is, given infinite space and finite combinatorics, duplication is not possible. It is mandatory. Now, before we go any deeper, it is worth pausing to be honest about the word mainstream. The implication of infinite copies of you is mainstream in the sense that it follows directly from premises: infinite space, uniform physical laws, finite quantum states that are themselves mainstream. The individual ingredients are accepted by the broad community of cosmologists. The conclusion is, in the words of Tegmark himself, something most physicists believe in implicitly, but rarely state out loud. It is not a fringe claim. It is a consequence that respectable physics journals print, and that working cosmologists reference without particular alarm. What makes it feel strange is not its status within physics, but the fact that its implications have not yet been fully absorbed into the way ordinary people think about themselves and their place in the universe. That absorption is what this exploration is for. So we begin at the most modest and least controversial level. The level where copies of you arise not from exotic new physics, but simply from the fact that the universe is very, very large. This is what Tegmark calls the level 1 multiverse, and it is worth dwelling on how little it requires. It requires no new laws of physics. It requires no undiscovered particles. It requires no mechanism beyond the one already implied by our best measurements of cosmic geometry. It requires only what the Planck satellite already suggests: that space extends, flat and populated, far beyond the horizon of what we can see. Pause here, because this is important. Everything we will build on top of this, the more exotic levels, the stranger claims, the deeper implications, rests on a foundation that is, by the standards of contemporary physics, essentially conservative. The claim that there are copies of you beyond the cosmic horizon is not the most speculative thing we will discuss tonight. It is the least speculative. It is on the ground floor. And once you understand why even the ground floor produces infinite copies, the additional stories above it, each more elaborate, each requiring more physics, each producing copies that differ from you in ways ranging from subtle to profound, become not more incredible, but more inevitable. Before we climb to those higher levels, though, we need to sit a while longer on the ground floor and understand it properly. Because the standard picture of the observable universe, the one most of us carry around, is subtly wrong in a way that matters. The textbook answer, the version most people carry from school, is something like this. The Big Bang happened approximately 13.8 billion years ago, and the universe has been expanding ever since. And the observable universe is roughly 93 billion light-years across, because space itself has been expanding and carrying galaxies along with it. And the cosmic microwave background is the oldest light we can see. And beyond that is the edge of what exists. The first part of that picture is correct. The second part, beyond that, is the edge of what exists, is where the apparent simplicity of the textbook version collapses. The cosmic microwave background is not the edge of the universe. It is the edge of the transparent universe. In the first 380,000 years after the Big Bang, the universe was so hot and dense that photons could not travel freely. They were constantly scattered by charged particles in a plasma so thick it was opaque. Then, approximately 380,000 years after the Big Bang, the universe cooled enough for electrons and protons to combine into neutral hydrogen atoms in an event cosmologists call recombination. The universe became transparent. Photons were suddenly free to travel, and they have been traveling ever since. And today we detect them as the cosmic microwave background. But what lies beyond the surface of last scattering? Beyond the shell from which those ancient photons were emitted? Matter, more space, more of the same universe that produced our observable region. The cosmic microwave background is not a wall, it is a veil. And beyond the veil, as far as our theoretical understanding extends, the universe continues. David Spergel at Princeton University, who led the WMAP team, the Wilkinson Microwave Anisotropy Probe, which gave us the first high-resolution maps of the cosmic microwave background, spent years analyzing the statistical patterns in that ancient light for evidence of a finite universe. Specific anomalies that would appear if space curved back on itself at a particular scale. He and his colleagues found no such evidence. The universe, on the scales accessible to us, shows no sign of closure. This is not proof of infinity. It is evidence consistent with infinity in a universe where direct proof of what lies beyond our horizon is, by definition, inaccessible to us. We cannot send a signal beyond the cosmic horizon. We cannot receive a signal from beyond it. The region beyond our observable bubble is, in the most literal sense, causally disconnected from us. Events out there cannot affect events here, and vice versa, because the distance light would have to travel to connect them exceeds the distance light has had time to travel since the beginning of the universe. And yet, that disconnection does not mean those regions do not exist. It means only that we cannot observe them directly. Their existence is inferred from the same logic that tells us the floor exists beneath a table covered by a long tablecloth. We cannot see it, but we have no reason to think it stops. This inference, from the flatness of space, from the uniformity of the cosmic microwave background, from the absence of any detectable boundary, points in one direction, outward, into a universe that continues far beyond what any instrument we will ever build can detect, populated by matter arranged according to the same laws, governed by the same constants, producing the same physics we observe here. And in that unlimited extension, producing, with mathematical certainty, every possible arrangement of atoms that can exist in a volume the size of ours, including you, not a distorted echo, not a rough approximation, not someone who grew up in the same house but made different choices at the crucial moment. you, the arrangement of approximately 7 octillion atoms, 7 followed by 27 zeros, that constitutes your body and brain right now, with the specific electrochemical patterns that constitute your memories, your current experience, the precise texture of what it is like to be you at this moment. That arrangement is finite. It is large, but it is finite. Against the backdrop of infinite space, it is, statistically speaking, not rare. It is not even uncommon. It is a pattern that the universe writes and writes again and will write an infinite number of times across distances that make the observable universe seem like a single grain of sand on an infinite beach. This is the view from the ground floor, and the ground floor alone is already enough to dissolve, quietly and permanently, the intuition that you are singular. Now take stock of where we are before we climb higher. We have established that the observable universe, that 93 billion light-year sphere of space that contains 2 trillion galaxies and everything we have ever measured or detected, is almost certainly a small, causally isolated pocket within a far larger whole. We have established that the geometry of space, as measured by the Planck satellite and its predecessors, is flat to within our best precision, and that flat geometry is the natural geometry of infinite extent. We have established that in an infinite universe with finite combinatorics, repetition is not a possibility, but a mathematical requirement, and that this requirement produces, at a distance of roughly 10 to the 10 to the 29th meters, an exact copy of you. That was level 1. It required nothing more exotic than a very large universe. Now we climb. But before the climb, one more thing deserves attention on the ground floor, because it is the kind of thing that sounds straightforward, but quietly contains a puzzle that philosophers and physicists have been wrestling with for decades. The puzzle is this: what does it mean for a copy of you to be you? The question is not merely semantic. It touches something fundamental about the nature of identity, consciousness, and the relationship between physical arrangement and experience. When we say that 10 to the 10 to the 29th meters away, there exists an exact copy of you, we are saying that there exists a physical system composed of the same kinds of atoms in the same spatial relationships, running the same electrochemical processes, having the same memories, experiencing, subjectively from the inside, what feels like the same stream of consciousness you are experiencing right now. Is that you? The materialist answer, the answer implied by physics, is yes. If there is no non-physical ingredient to consciousness, if what you are is entirely constituted by the physical arrangement of matter and the processes that arrangement supports, then a physically identical arrangement is you in every sense that matters. There is nothing extra to be. There is no further fact about which of the two arrangements is the real you. Both are equally real. Both are equally you. The uncomfortable edge of this answer is what the philosopher Derek Parfit spent much of his career probing in his 1984 work, Reasons and Persons. Parfit argued that personal identity, when examined carefully, is less determinate than we instinctively believe. The self is not a further fact over and above the physical and psychological continuities that constitute it. This insight, arrived at through philosophy, rhymes strangely with the cosmological picture we have been building, a picture in which the boundaries of the self dissolve outward into a universe that is, in some sense, full of selves exactly like this one. We will return to this puzzle. For now, hold it lightly, the way you might hold a stone picked up on a walk, not examining it yet, just aware of its weight in your hand. Now we climb. The second level of the multiverse hierarchy requires us to understand what happened in the universe's very first moments. And to understand that, we need to understand inflation, one of the most successful and most philosophically vertiginous ideas in the history of physics. In 1980, Alan Guth, then a postdoctoral researcher at the Stanford Linear Accelerator Center, proposed a mechanism to explain three puzzles that had been nagging at cosmologists for years. The first was the horizon problem. Why does the cosmic microwave background look so uniform in every direction? The same temperature to within 1 part in 100,000, when regions on opposite sides of the sky were, according to standard Big Bang cosmology, never in causal contact with each other. They never had time to exchange information and reach thermal equilibrium, and yet they are at the same temperature. Why? The second was the flatness problem. The universe today is very close to spatially flat, which means that its energy density is very close to the critical density, the precise value at which gravity and expansion exactly balance. But flatness is an unstable condition. A universe that starts slightly curved becomes more curved over time, the way a ball perched on the top of a hill rolls away from the top. For the universe to still be flat today, it must have started with a flatness tuned to an almost incomprehensible precision, approximately 1 part in 10 to the 60th in the first second of its existence, depending on the model used. Why would nature tune a parameter so precisely? The third was the magnetic monopole problem, which is more technical, but amounts to asking why we do not observe a certain class of exotic particles, magnetic monopoles, that grand unified theories of particle physics predict should have been produced abundantly in the hot early universe. Guth's solution was elegant. He proposed that in the first tiny fraction of a second after the Big Bang, a period far shorter than any timescale we can intuitively grasp, on the order of 10 to the negative 36 seconds, the universe underwent a period of extraordinarily rapid exponential expansion, driven by a form of energy embedded in the quantum fields permeating space. This expansion was not merely fast, it was breathtaking. In a time shorter than it takes light to cross a single proton, the universe inflated by a factor of at least 10 to the power of 26. More likely, far more. The horizon problem dissolves because regions that appear causally disconnected today were in causal contact before inflation stretched them apart. The flatness problem dissolves because inflation drives any initial curvature toward zero, the way inflating a balloon drives its surface toward flatness. The monopole problem dissolves because inflation dilutes any monopoles produced before it, spreading them so far apart that we would not expect to find one in our observable region. Inflation solved three major problems at once. That is the kind of explanatory elegance that makes physicists take a theory seriously. But inflation came with a consequence that Guth and others quickly recognized, and that has grown over the decades since into one of the most philosophically significant ideas in modern cosmology. That consequence is eternal inflation. In 1983, Andrei Linde at the Lebedev Physical Institute in Moscow, building on and reformulating Guth's original proposal, and later in close dialogue with Guth, developed what he called chaotic inflation. In Linde's version, inflation does not begin with a carefully tuned initial state. Instead, it arises naturally from the random quantum fluctuations of a scalar field in the early universe. Given a large enough initial patch of space, inflation will begin somewhere, driven by regions where the field happens to sit high on its potential energy curve. And here is the crucial part. As inflation proceeds, quantum fluctuations are constantly jostling the inflaton field, the field driving the expansion, both upward and downward. In most regions, the field rolls down its potential energy curve. Inflation slows and eventually ends, producing a hot, dense region of ordinary matter and energy, what we would recognize as a Big Bang and its aftermath. That region becomes a pocket universe, a bubble of post-inflationary space embedded in the still inflating background. But in some regions, randomly, unavoidably, driven by quantum mechanics, the field gets kicked upward instead of downward. Those regions inflate faster, grow larger, and produce more volume from which new fluctuations can kick the field upward again. Linda showed in 1986 that chaotic inflation is self-reproducing. The volume of space still undergoing inflation grows faster than the volume that stops inflating and becomes pocket universes. Inflation, once started, does not end globally. It ends locally in isolated patches while continuing and accelerating everywhere else. This is eternal inflation. The inflating background never stops. Pocket universes bud off from it continuously, like bubbles forming on the surface of a boiling liquid, each one becoming a vast region of post-inflationary space with its own temperature, its own matter distribution, its own eventual history of galaxy formation and stellar evolution. Our universe, everything within our cosmic horizon, and the vast level 1 region beyond it, is one of those bubbles, and the bubbles never stop forming. In an eternally inflating background, the number of pocket universes is not merely large. It is, over infinite time, infinite. Alan Guth, in a 2007 paper titled Eternal Inflation and Its Implications, which remains one of the clearest statements of this scenario, described the situation bluntly. In an eternally inflating universe, anything that can happen will happen, and it will happen an infinite number of times. This is the level 2 multiverse, and it differs from level 1 in a crucial way that deepens the strangeness considerably. At level 1, all the copies of you exist within a single continuous space. They inhabit the same universe you do, the same physical laws, the same fundamental constants, the same particle physics. They are far away, unreachably far away, but they are in principle part of the same connected fabric of space-time. If you imagine the universe as an ocean, level 1 copies are on the other side of that ocean, too far to ever reach or signal, but swimming in the same water. Level 2 copies are in different oceans, because each pocket universe forms when the inflatant field reaches a different configuration as it ends inflation. And because the fundamental constants of physics, the strength of gravity, the mass of the electron, the cosmological constant, the charge of the proton, are determined not by some deep necessity, but by the particular quantum state in which inflation ends, different pocket universes can have different physical constants. The same inflatant field, ending inflation in a different way, produces a universe where gravity is slightly stronger, or the electron is slightly heavier, or the cosmological constant, the energy density of empty space, takes a different value. Most of those universes are dark and sterile. A universe where the strong nuclear force is slightly weaker cannot form atomic nuclei. And without nuclei, there are no atoms, no molecules, no chemistry, no life. A universe where the cosmological constant is even slightly larger than ours would expand so quickly that matter could never clump into galaxies. Without galaxies, there would be no stars. Without stars, no heavy element synthesis. And without heavy elements, no biochemistry. The range of possible constant combinations is enormous, and most of that space is devoid of complexity. But some pockets, a small fraction, land on values of the constants that permit the formation of complex structures, stars, planets, chemistry, biology, minds. Our universe is one of those lucky pockets, and the reason it is lucky is not that the constants were designed to be life-friendly. The reason is that only in pockets where the constants fall within life-permitting ranges do observers exist to notice the values. The others are vast and dark and contain no one to ask why. This is the anthropic principle in its cosmological form, and it is a genuinely subtle idea, not a trivial tautology, but a real selection effect that, once taken seriously, changes the way we frame the question of why our constants are what they are. The physicist Alexander Vilenkin at Tufts University has spent much of his career developing the formal implications of eternal inflation, including the problem of how to assign probabilities to observations in an eternally inflating multiverse. A problem that turns out to be surprisingly difficult, because when you have infinite numbers of everything, ratios become ambiguous. Vilenkin's 2006 book, Many Worlds in One, is one of the clearest popular accounts of what eternal inflation implies for the structure of reality, and his technical work on the measure problem, how to make sense of probabilities when everything happens infinitely often, remains one of the central open problems in cosmological theory. The measure problem is worth flagging here as our first explicit admission of genuine scientific uncertainty. We do not know how to assign probabilities in an eternally inflating universe. The standard tools of probability theory require a well-defined reference class, a set of outcomes with known relative frequencies, and in a universe where every possible outcome happens infinitely often, defining that reference class is not straightforward. Different proposals for solving the measure problem give different answers to questions like, how likely is it that an observer in a random pocket universe sees constants like ours? Some proposals give answers consistent with observation. Others do not. The problem is unsolved, and researchers including Guth, Linde, Vilenkin, and others have been working on it for decades without reaching consensus. This uncertainty does not undermine the basic architecture of eternal inflation. It complicates our ability to make precise predictions from it. The distinction matters. We can believe in the broad picture, infinite pocket universes with varying constants, without being able to calculate the probability of finding ourselves in a universe exactly like ours. Now, hold the two levels together. At level 1, copies of you exist in distant regions of the same post-inflationary space, identical down to the atom, simply because infinite space with finite combinatorics guarantees it. At level 2, an infinite number of pocket universes exist, most with different physical constants, but some a non-zero fraction of an infinite number, with constants close enough to ours that complex structures form, and among those structures, some with constants close enough to ours that the same atomic physics operates, and among those, some that produce, through the same evolutionary and developmental processes that produced you, arrangements of matter that are, again, exactly like you. The copies multiply, and we have not yet reached the strangest level. Before we go there, stand back for a moment and look at the architecture we have assembled so far. At the base, a universe whose spatial geometry points toward infinite extent. Above that, a mechanism, eternal inflation, that naturally produces an infinite number of pocket universes with varying physical properties. Each of these structures was proposed not to explain copies of you, not to satisfy some philosophical appetite for plenitude, but to solve specific, concrete problems in observational cosmology. Inflation explains the uniformity and flatness of the cosmic microwave background. Eternal inflation is the generic, almost unavoidable consequence of inflation once quantum mechanics is taken seriously. The copies are not the point of these theories. They are a side effect. They are what you get when you follow physics honestly and do not flinch at the implications. And the implications are not finished. Picture the cosmos as it appears from this level of our hierarchy. Not a single universe, but a vast, possibly infinite foam of pocket universes, each one a bubble of post-inflationary space, each one containing its own level 1 region and its own level 1 multitude of copies, each one governed by its own physical constants, the vast majority dark and featureless, a small fraction bright with stars and chemistry, and the improbable complexity of life. This is the Level 2 multiverse, and it is, by any reasonable measure, the most cosmologically conservative version of the multiverse idea, the version that falls most directly out of the physics we already accept. But even here, the question of you has already changed its character. At Level 1, the question was about distance. How far away is the nearest copy? At Level 2, the question becomes richer. How many pockets have the right constants for you to arise? How many separate lineages of complexity, in how many separate bubbles of post-inflationary space, independently converge on the same physical arrangement that is you? The answer is not a number we can calculate precisely because of the measure problem. But the answer is almost certainly not 0. And in an infinite multiverse, not 0 means infinite. Infinite copies of you, arising independently in pocket universes that may share your fundamental constants, but began their histories separately, evolved their stars separately, coalesced their planets separately, sparked their biochemistry separately, walked their evolutionary paths separately, and arrived at the end of all that independent history at the same extraordinary specificity, the configuration of atoms and processes that constitutes you. This is where the argument begins to feel not merely surprising, but philosophically vertiginous. Because at Level 1, the copies of you share your history. They went through the same cosmic evolution, the same stellar nucleosynthesis, the same planetary formation, the same biological evolution, the same developmental sequence that produced you. The copy at 10 to the 10 to the 29th meters away has lived your life, made your choices, had your experiences. They are you in the deepest possible sense. At Level 2, the copies share your physical constitution, but not necessarily your history. They are you in the sense that they are the same arrangement of matter. But the path that led to that arrangement was different. A different bubble, a different history of stars and geology and evolution, a different sequence of contingencies that happened to converge on the same endpoint. These copies are, in a sense, you without your past. You are a physical type rather than a historical individual. The distinction matters. It points toward a question that will deepen as we climb higher. What makes you you? Is it your physical arrangement, your history, your continuous stream of experience, your memories, your choices? The question is not rhetorical. It is a genuine puzzle, and the different levels of the multiverse hierarchy illuminate different facets of it. We will carry that puzzle with us as we climb. But first, one more thing about Level 2 that deserves careful attention: the role of the string theory landscape. In the early 2000s, a convergence of ideas in theoretical physics, specifically in string theory, the leading candidate for a unified theory of quantum gravity, produced a picture that startled even those who had been thinking about eternal inflation and multiple universes for decades. String theory, in its various formulations, predicts not a single unique vacuum state, a single set of physical constants, but an enormous landscape of possible vacuum states, each corresponding to a different way that the extra dimensions of string theory can be compactified and stabilized. The number of these possible vacuum states is estimated at somewhere around 10 to the power of 500. This is a number so large that even listing the number of digits it contains would require a number too large to write. In the string landscape, each vacuum state corresponds to a different set of physical constants, a different universe with different particle masses, different force strengths, different dimensionality, different cosmological constant. Most of these vacua produce universes, nothing like ours. A small fraction produce universes where atoms can form and stars can burn. An even smaller fraction produces universes where the constants are close to ours. Leonard Susskind at Stanford University, who coined the term landscape for this idea and developed much of its formal basis in the early 2000s, argued that the landscape is not a problem for string theory, but its most important prediction. Combined with eternal inflation, which naturally populates different vacuum states in different pocket universes as the inflatant field settles into different valleys of the landscape. The string landscape gives a concrete physical mechanism for why our universe has the constants it has. Not because they were tuned by design, but because in a landscape of 10 to the 500 possibilities, all of them are realized, and observers can only find themselves in pockets where the constants permit observers to exist. The string landscape is deeply controversial. Not all string theorists accept it. Not all physicists accept string theory. Some, including David Gross at the University of California, Santa Barbara, who shared the Nobel Prize in Physics in 2004 for his work on the strong nuclear force, have argued that the landscape represents a failure of predictivity. A theory that can accommodate any observation is not making real predictions. Others have argued that the landscape is the honest consequence of taking mathematics seriously, and that our discomfort with it reflects a philosophical preference for uniqueness that the universe is not obligated to share. Both perspectives deserve to be held. The landscape is not established physics in the way that inflation is established physics. It is a serious proposal from serious physicists that connects two of our best theoretical frameworks, string theory and inflation, in a way that naturally produces the kind of multiverse we have been describing. Its status is plausible, consequential, contested, and not yet falsifiable by any measurement we know how to make. We carry that uncertainty openly as we carry the measure problem. These are real limits on what we know. The architecture of the argument does not depend on resolving them, but honesty requires acknowledging them. And acknowledging them is part of what it means to think about these questions carefully. Now we reach the third level. And here the argument takes a turn that many people find more startling than anything we have discussed so far, because it comes not from cosmology or inflation or string theory, but from quantum mechanics, the theory of the very small, the theory that describes the behavior of particles and fields at the most fundamental level we have access to. The theory that, since its development in the 1920s and 1930s, has never made a wrong prediction about a measurable quantity, and whose interpretation has never been fully agreed upon by the physicists who use it. The quantum multiverse, level 3 in Tegmark's taxonomy, arises from taking quantum mechanics seriously in a specific way that many physicists resist, but that the mathematics itself seems to demand. Here is the setup. Quantum mechanics describes physical systems using a mathematical object called the wave function. The wave function of a particle does not say where the particle is. It says, in essence, where the particle might be. It is a superposition of all possible states, each with an associated probability amplitude. When you measure the particle, you get a single definite outcome. Before the measurement, the particle is not in one state. It is in all of them simultaneously, weighted by the wave function. The textbook answer to what happens when you make a measurement is something called the Copenhagen interpretation, developed primarily by Niels Bohr in the late 1920s and formalized over the following decade. In the Copenhagen interpretation, the wave function collapses upon measurement. The superposition of possibilities resolves into a single actuality. You get a definite outcome because the act of measurement causes the wave function to collapse to one of its possible states, with probability given by the squared amplitude. This answer has always carried a faint whiff of unsatisfactoriness. What counts as a measurement? What triggers the collapse? Why should the act of observation, by a macroscopic classical detector, cause a fundamental change in the quantum state of the system? The Copenhagen interpretation, for all its practical success, never answered these questions cleanly. It was, in a sense, a pragmatic framework. Do the calculation this way, and the predictions will match the experiment. Do not ask too hard about what the wave function really is. In 1957, a Princeton graduate student named Hugh Everett III proposed an alternative that took the mathematics of quantum mechanics completely seriously without introducing a collapse mechanism. In Everett's formulation, the wave function never collapses. Measurement is just another physical interaction, governed by the same quantum mechanical equations as everything else. When a quantum system interacts with a measuring device, and the measuring device interacts with an observer, the result is not a collapse to one outcome, but an entanglement. The wave function of the combined system, quantum particle plus detector plus observer, enters a superposition of all possible outcomes. Every possible measurement result occurs. Every possible outcome is realized. But then why do we experience only one outcome? Why does the measuring device show a single reading? Why do we remember seeing one result, not a blur of all of them? Everett's answer: because each outcome is experienced by a different branch of the wave function. When a measurement occurs, the wave function of the universe branches. In one branch, the detector reads one value and the observer records that value. In another branch, the detector reads a different value and the observer records that. Both branches are real. Both contain observers who experience definite single outcomes. The appearance of collapse, the apparent selection of one outcome from many, is an illusion produced by the fact that branches, once separated by the process of quantum decoherence, never recombine and interfere. Each branch contains observers who, by the physics of their situation, can see only their own branch. This is the many worlds interpretation of quantum mechanics. And it implies that with every quantum event, every radioactive decay, every photon absorption, every electron spin measurement, every particle interaction, the universe branches, silently and without any physical mechanism, into as many copies of itself as there are distinct possible outcomes. The number of branches generated per second across all the quantum events occurring in all the atoms of all the matter in the observable universe is not a number that can be usefully written down. It is effectively uncountable, and each branch is a complete universe containing copies of everything that existed before the branch point, diverging in whatever way the outcome of that quantum event implies. This is level 3. And here is what makes it especially interesting in the context of our exploration. The copies of you that exist at level 3 are not far away. They are not in distant regions of infinite space. They are not in other pocket universes formed by eternal inflation. They are here, in the same space-time, in branches of the wave function that are orthogonal to your branch, meaning they cannot interact with or be detected by your branch, but are equally real in the same mathematical sense that your branch is real. At level 3, The copies diverge from you, not over cosmological distances, but at every moment, with every quantum event that occurs inside your body or in the environment around you. Your copy at level 3 is the version of you in whom a particular cosmic ray, striking a DNA molecule in one of your cells 10 seconds ago, caused the electron that absorbed it to spin the other way, failing to trigger the chemical reaction it triggered in your branch, leaving your DNA intact in a way that will, decades from now, matter in ways neither you nor your copy can currently anticipate. That copy is reading these same words. That copy has the same memories you have. That copy diverged from you so recently, at such a microscopic level, that they are, for all practical purposes, you. And that divergence is happening right now in every atom, in every moment. The many worlds interpretation is not universally accepted. It has strong defenders. David Deutsch at Oxford University, who in 1985 published what is considered the first serious technical argument for many worlds, and Sean Carroll, now Homewood Professor of Natural Philosophy at Johns Hopkins University, who in recent years has developed the most systematic modern defense of the interpretation, arguing in his 2019 book, Something Deeply Hidden, written during his time at Caltech, that many worlds is not merely one interpretation among several, but is the straightforward reading of what the quantum formalism actually says. It also has serious critics who raise concerns about how probabilities work in a framework where all outcomes occur, and about the ontological cost of positing an enormous and undetectable proliferation of branches. But here is what is not disputed. The mathematics of quantum mechanics, taken at face value, without any additional collapse postulate, produces the branching structure Everett described. The question is not whether mathematics does this. It does, provably, by the linearity of the Schrödinger equation. The question is whether mathematics should be taken at face value, or whether some additional physical process, some collapse mechanism, should be added to select a single outcome. The Copenhagen interpretation adds a collapse. Many worlds do not. And in the absence of a collapse mechanism, we have directly observed or tested, adding one is, in a sense, the more philosophically adventurous move. We do not need to resolve this debate tonight. What we need to take from it is the shape of the claim that quantum mechanics, on its most natural reading, produces a constantly branching universe in which every possible quantum outcome is realized, and in which copies of you, versions that diverged from you at every scale from the cosmological to the subatomic, exist in a structure that is, in some sense, the same place you are, just unreachable by you. 3 levels, 3 different mechanisms, 3 different reasons why the universe might be constitutionally incapable of containing only one of you. And we have not yet reached the 4th level. The 4th level demands a different kind of preparation. Not the preparation of learning new physics, though new physics is involved, but the preparation of slightly loosening the hold of a deeply rooted assumption. An assumption so fundamental that most of us have never consciously questioned it. The idea that mathematics describes reality rather than the idea that mathematics is reality. These sound like the same thing. They are not. When a physicist writes down an equation, the Schrödinger equation, say, or Einstein's field equations, or Maxwell's equations for electromagnetism, the conventional understanding is that the equation is a map, a representation, a human-constructed symbolic system that happens to correspond with extraordinary precision to the behavior of things that exist independently of the map. The territory is out there. The map is in our heads. The map is useful because it accurately captures features of the territory. But the territory is primary, and the map is secondary. Reality first, mathematics after. This is the common sense view. And it is wrong, or at least it may be wrong, in a way that Max Tegmark has spent the better part of 2 decades trying to articulate clearly and defend rigorously. Tegmark's Level 4 multiverse rests on what he calls the mathematical universe hypothesis. The hypothesis is simple to state and difficult to fully absorb. Our physical universe is not described by mathematics. It is a mathematical structure, not a physical thing that happens to obey mathematical laws. A mathematical object existing in the same way that the set of integers exists, or the way Euclidean geometry exists, as an abstract structure whose properties are determined entirely by its internal logical relationships, with no reference to anything outside itself. If this is true, and we will return to the question of what kind of truth it could be, then the distinction between mathematical existence and physical existence collapses. Every mathematical structure that is consistent and well-defined exists physically, in exactly the same sense that our universe exists. The universe is not a special, privileged mathematical structure that someone chose to instantiate while leaving the others merely abstract. It is one member of an infinite ensemble of existing mathematical structures, each equally real, each containing whatever observers can exist within it. This is the Level 4 multiverse, and it is, by any measure, the most radical of the 4 levels, the one that requires the greatest departure from ordinary intuition, the one that has attracted the most philosophical criticism, and the one that, if true, has the most profound implications for the question of what it means to exist. Before we examine those implications, it is worth asking why a physicist, and a serious, well-credentialed one, would propose something that sounds, at first hearing, more like metaphysics than physics. The answer lies in a question that has puzzled physicists and philosophers since at least the 1960s, when the physicist Eugene Wigner gave it a famous name: the unreasonable effectiveness of mathematics in the natural sciences. Wigner's observation, made in a 1960 essay that remains widely read and widely unresolved, was that the mathematical structures developed by mathematicians for purely abstract reasons, with no reference to physical application, often centuries before any physical application was imagined, turn out, again and again, to be precisely the structures needed to describe the physical world. Non-Euclidean geometry, developed by Bernhard Riemann in the 1850s as a pure mathematical exercise, turned out to be exactly the mathematics needed for Einstein's general theory of relativity, published 60 years later. Group theory, developed by Évariste Galois in the early 19th century in the context of abstract algebra, turned out to be the mathematical language of particle physics. Complex numbers, which mathematicians invented to solve equations that had no real solutions, turned out to be not merely useful, but essential for quantum mechanics, not as a computational convenience, but as a fundamental feature of how nature works. Why would an abstract mathematical structure, developed with no reference to the physical world, be the perfect language for describing that world? If mathematics is merely a map we draw, why should maps drawn for entirely other purposes fit the territory so precisely? One answer is that mathematics is, in some sense, the only possible language for precise description, and so, of course, it works. But this answer is not fully satisfying, because it does not explain why such specific mathematical structures, the ones physicists actually need, keep appearing in pure mathematics long before they appear in physics. Tegmark's answer is that there is no coincidence here, because there is no distinction. The physical universe is a mathematical structure. It does not obey the equations of quantum field theory and general relativity as if following external rules. It is those equations, in the sense that it is those abstract relationships existing as mathematical structure. The unreasonable effectiveness of mathematics is explained by the identity of mathematics and physics. Mathematics does not describe reality. Mathematics is reality. This is the kind of idea that is easy to state and hard to test. Tegmark has tried to make it testable in the limited sense of identifying conditions under which it would be falsified, primarily by showing that our physical universe contains features that no mathematical structure could have. So far, no such features have been identified, but the absence of falsification is not the same as confirmation, and the mathematical universe hypothesis remains a philosophical proposal whose empirical status is genuinely contested. What is not contested is its implication for the question of copies. If the level 4 multiverse is real, if every consistent mathematical structure exists physically, then the ensemble of existing realities is not merely the infinite set of pocket universes with varying physical constants. It is the infinite set of all possible physical realities. Universes with different numbers of dimensions, universes with different particle content, universes with different types of forces, universes whose fundamental laws have no resemblance to ours, universes so alien that no translation between them and our universe is possible. Within that infinite ensemble, the pattern that is you, the mathematical structure of your physical arrangement, exists not merely in your own universe or in copies of your universe, but in every mathematical structure that is complex enough to contain that pattern, which is, in an infinite ensemble, an infinite number of structures. The copies at level 4 are the most alien and the most intimate simultaneously. They are you in the sense that they instantiate the same mathematical relationships that constitute you. But they may be embedded in a physical reality so different from ours that nothing else around them resembles anything we know. A you in a universe with different dimensions, different physics, different everything, except the precise mathematical pattern of your own existence. This is where the argument reaches its outermost boundary. Not the boundary of space, not the boundary of inflationary regions, not the boundary of quantum branches, but the boundary of mathematical possibility itself. And at that boundary, the concept of you has been stretched so far from its ordinary meaning that it becomes unclear whether the word still applies. This is not a failure of the argument. It is a success. The argument has done what good philosophical investigation is supposed to do. It has taken a concept we use casually, the concept of yourself, of your identity, of your uniqueness, and followed it into territory where its edges become visible, where you can see, for the first time, what the concept is made of and where it dissolves. We will return to this boundary. For now, we have the full architecture of the hierarchy in place. 4 levels, 4 mechanisms, 4 ways in which the universe may be constitutionally committed to producing not one of you, but infinitely many. Now we need to go back down through those levels and examine, carefully and honestly, the objections, because the argument for infinite copies is not without difficulties. And the difficulties are serious enough that several respected physicists and philosophers have rejected the entire framework, not out of squeamishness or insufficient imagination, but for reasons that deserve respectful attention. The first and most fundamental objection is the one we have already touched on, the problem of falsifiability. A scientific claim is falsifiable if there exists some observation or experiment that could, in principle, prove it wrong. The pocket universes of level 2 eternal inflation are, by construction, beyond our cosmic horizon. We can never send a signal to them or receive a signal from them. No observation we can make in our universe can directly confirm or deny their existence. By the criterion of falsifiability, the criterion associated with Karl Popper and widely used in philosophy of science, a claim about regions beyond the cosmic horizon is not a scientific claim at all. It is metaphysics. Tegmark, Guth, Lind, and others who defend the multiverse have responded to this objection in several ways. The most common response is that falsifiability applies to theories, not to individual predictions of theories. The theory that predicts level 2 pocket universes, eternal inflation, makes other predictions that are, in principle, testable. The statistical distribution of constants in our universe, the spectrum of fluctuations in the cosmic microwave background, the large-scale structure of matter. If eternal inflation as a framework is confirmed by those testable predictions, then accepting its untestable prediction, the existence of other pocket universes, is not a violation of scientific reasoning, but an instance of it. We accept the existence of the Big Bang, of the first fraction of a second of the universe's history, even though we cannot directly observe it, because the framework that implies it also implies things we can observe. A second response is that the boundary between science and metaphysics is itself contested. Paul Steinhardt at Princeton University, one of the original architects of inflationary cosmology, who has since become one of its most prominent critics, has argued that eternal inflation is not falsifiable and therefore should not be counted as science. But Steinhardt's own alternative, a cyclic cosmology in which the universe undergoes repeated cycles of expansion and contraction driven by an extra spatial dimension, faces similar challenges. The difficulty of falsifiability may be a feature of all cosmological theories that make claims about regions or processes beyond our horizon, not a specific weakness of inflation. A third response, offered by Tegmark and others, is that the existence of other level 1 regions, the simplest copies, is not really more controversial than the existence of any region of space beyond the horizon. We accept, without philosophical anguish, that there are galaxies beyond the reach of our best telescopes, that there are regions of space from which no light has yet had time to reach us. The level 1 copies are simply regions of space that are very far away. Their unobservability is a matter of distance, not of kind. If we are willing to accept the existence of unobservable galaxies, why should we resist the existence of unobservable copies? The second major objection is more specific and more technical. It concerns the infinite copies argument and the mathematics of infinity. The argument for copies rests on the claim that in an infinite universe with finite combinatorics, every possible configuration of matter is realized. But this argument implicitly assumes that matter is distributed randomly and uniformly across infinite space, that the universe is, in the technical sense, ergodic. If matter is distributed in a highly non-uniform way, if the universe has large-scale structure on scales beyond our horizon that prevents uniform sampling of all possible configurations, then the guarantee of repetition breaks down. Against this objection, the inflationary framework again provides support. Inflation naturally produces a universe that is highly homogeneous and isotropic on large scales, with random quantum fluctuations providing the initial seeds for structure. The large-scale homogeneity we observe in our cosmic region is exactly what inflation predicts, and there is no mechanism in the standard picture that would produce systematic, large-scale inhomogeneity beyond our horizon. The third objection is perhaps the deepest, and it concerns the meaning of the copies themselves. Even granting that there exist, in distant regions of infinite space, Physical systems whose atomic configurations are identical to yours? Does it follow that those systems are you, or that they have experiences at all? This is the hard problem of consciousness applied to the multiverse context, and it resists easy resolution. The physicist and mathematician Roger Penrose at the Mathematical Institute of the University of Oxford has argued for decades that consciousness cannot be fully explained by classical computation, that it involves quantum processes in the brain, specifically in structures called microtubules within neurons, that go beyond what current neuroscience and physics can account for. If Penrose is right, then an atomic copy of you might not be a conscious copy of you, because consciousness depends on quantum processes that could differ between copies, even when the classical atomic arrangement is identical. Penrose's theory, the orchestrated objective reduction hypothesis, developed in collaboration with Stuart Hameroff, is highly controversial and has not been confirmed experimentally. But its existence as a serious proposal by a serious mathematician is a reminder that the claim that atomic identity implies experiential identity rests on assumptions about consciousness that we do not fully understand. Here is the second explicit admission of genuine scientific uncertainty we must make. We do not know what consciousness is, how it arises from physical processes, or whether an exact physical copy of a person would be a conscious person. The argument for copies assumes that consciousness is entirely determined by physical arrangement. That assumption may be correct, it may not be. We cannot currently resolve it, and any honest account of the infinite copies argument must carry this uncertainty openly. With those objections noted, and they are real and they matter, we turn back to the structure of the argument and follow it where it leads. Because even granting the objections, even holding the uncertainties openly, something profound has already happened. We have established that several of our best theoretical frameworks in physics, inflationary cosmology, quantum mechanics, string theory, all point independently and from different directions toward the same conclusion: that our observable universe is not the whole story. That reality is vastly larger than what we can see. That the pattern of matter and energy and structure and complexity we call our universe is one instance of a process that generates, at minimum, an enormous number of other instances, and quite possibly an infinite number. The copies may or may not be conscious. The infinite space may or may not be real. The many worlds branches may or may not constitute independent realities. But even at its most conservative, the picture that emerges from following our best physics, honestly, is one in which the observable universe is not unique, not special, not the totality of what exists, but a small, local, temporary example of a much larger and stranger whole. And this is where the argument begins to pivot from the cosmological to the personal. Because the question of infinite copies is not ultimately a question about cosmology. It is a question about you, about what you are, about what it means to be a specific, particular, unrepeatable individual in a universe that may be constitutionally committed to repeating you. Take a moment with that tension. It is real. It is not resolved by physics, and it is not resolved by philosophy. It sits in the space between them, and sitting with it honestly is, I would suggest, more valuable than resolving it prematurely. Here is the tension stated as clearly as possible. On one hand, you feel, with the immediacy and certainty of direct experience, that you are singular, that there is one of you, that your life is a unique thread of experience, beginning at birth and ending at death, and that no other thread in the universe is the same thread. This feeling is not a delusion. It accurately reflects something real about your situation, your causal history, Your continuous stream of experience, your specific sequence of moments and choices and relationships is singular. There is only one of you in the region of space you can access, in the branch of the quantum wave function you can observe, in the pocket universe you inhabit. On the other hand, the physics tells us that this singular thread is, in all likelihood, being woven simultaneously, not simultaneously in time, but simultaneously in the logical sense that it all exists, in an infinite number of other places and branches and pockets, by physical processes that are, from the outside, indistinguishable from the process that is weaving your thread right now. You are singular and infinite simultaneously, unique and ubiquitous, the only you in your world and one of infinitely many yous in the larger whole. How do you hold that? The temptation is to reach for one horn of the dilemma and let go of the other, to say, the copies don't really matter because I only have access to my own experience, and the copies are irrelevant to how I should live or what I should value. This is psychologically sensible and may even be practically correct, but it does not dissolve the philosophical puzzle. The copies exist, or they probably exist, regardless of whether they are relevant to your decisions. The other temptation is to say, if there are infinite copies of me, then my actions don't matter, because whatever I do here is being done differently by a copy somewhere else. This is also psychologically understandable and also does not hold up. Your choices matter in your branch, in your region, for the people in your life. The existence of branches where different choices are made does not change the reality or the weight of the choices you make here. A doctor who saves a patient's life does not thereby render the act meaningless by noting that in another quantum branch, the patient died anyway. But neither of these responses quite captures what the physics is pointing at. What the physics is pointing at is something stranger and, in a way, more generous. That the pattern you embody, the specific configuration of matter and process and experience that is you, is not a one-time accident in a universe that did not particularly mean to produce it. It is a pattern that the universe produces, reliably and repeatedly, wherever and whenever the conditions allow. Your existence is not arbitrary. It is not a fluke. It is, in some deep sense, natural. It is what the universe does given the right ingredients and the right conditions. You are not an accident. You are a recurrence. That reframing, from accident to recurrence, is not merely cosmetic. It changes the relationship between your existence and the universe you exist in. It suggests that the universe is, in some sense, hospitable to you, in a way that goes beyond the anthropic observation that we exist in a universe where life is possible. The hospitality is deeper. The universe does not merely permit you. Given sufficient scale, given sufficient space and time and quantum branching, the universe produces you, over and over and over. This is the pivot point, the place where the cosmological argument about copies becomes something else, something that touches not just the intellectual understanding, but the felt sense of what it means to be alive and aware in a universe of this scale and character. And this is also the place where the argument begins to reveal its most unsettling implication, the one that, once you see it, reorganizes everything that came before. Here it is. If the universe produces you infinitely, if every possible configuration of matter is realized somewhere in the level 1 expanse, and every possible pocket universe is realized in the level 2 foam, and every possible quantum branch is realized in the level 3 wave function, then the universe also produces every possible version of you. Not just the version sitting here, reading these words. Every version, every choice you did not make, every path you did not take, every version of you that went left instead of right at the crucial moment, that said yes instead of no, that stayed instead of left, that lived instead of died at the moment when, in your branch, you survived. All of those versions exist, somewhere. In some region of the level 1 expanse, a version of you made the choice you most regret. In some quantum branch, a version of you made the choice you most wish you had made. In some pocket universe with slightly different constants, a version of you never faced the choice at all. The full space of you, the complete set of all versions, all configurations, all histories, is not a set with one member. It is a set with infinite members. And your experience, the specific thread you are living, is one element of that infinite set, as real as all the others, and as particular. Take stock of where we are in this hierarchy. We began with level 1, infinite space producing copies through sheer extent. We climbed to level 2, eternal inflation producing pocket universes with varying constants. We reached level 3, quantum branching producing parallel versions at every moment. We ascended to level 4, the mathematical universe producing every possible reality. And throughout, we have been circling a question that none of these levels fully answers, but all of them illuminate from a different angle. What is the relationship between you, this specific thread of experience, and the infinite set of configurations and versions and copies that the physics tells us exist? We cannot know whether the level 3 branches constitute separate realities or merely separate terms in a mathematical description of a single reality. We cannot know whether the level 2 pocket universes exist in any physically meaningful sense, or whether eternal inflation is the right description of the universe's earliest moments. We cannot know whether the mathematical universe hypothesis is true, or whether it is a beautiful and instructive metaphysical error. We cannot know whether the distant level 1 copies are conscious, or whether consciousness is even the right concept to apply to physically identical configurations of matter. We cannot know these things, not because we have not tried hard enough, or because the instruments are not sensitive enough, or because the mathematics is not developed enough, but because these questions, at their deepest level, may lie outside the boundary of what observation and inference can reach. They are questions about what exists beyond any possible observation, about the nature of consciousness, about the relationship between abstract structure and concrete experience. These are questions at the edge of knowledge, not the retreating edge that moves as science advances, but the fixed edge, the place where the nature of inquiry itself imposes limits. And sitting with that limit, feeling it not as a frustration, but as a marker of how far the mind can reach, is, in itself, a kind of understanding. Something here deserves attention, because it is easy to miss in the cascade of levels and mechanisms and implications. The argument for infinite copies does not diminish you. That would be the naive reading. The thought that if there are infinite copies of you, you must be somehow less special, less significant, less worth caring about. This reading gets the logic exactly backward. What the argument actually reveals is that the pattern you embody, your physical constitution, your cognitive architecture, your capacity for experience, is not a local accident. It is a feature of reality that recurs as reliably as a mathematical truth wherever the conditions allow. Your existence is not diminished by being repeated. It is, in a strange and unexpected way, validated, confirmed, written into the structure of the universe not once, but infinitely. A musical theme does not become less beautiful because it recurs. A mathematical theorem is not less true because it can be proved in multiple ways. The pattern that is you is not less real less vivid, less worth living for, because it appears in other regions of the universe you cannot reach. What changes is the frame, and changing the frame is not a small thing. Most of us carry implicitly a frame in which our existence is a local event, something that happened once in this particular place and time, and will end once in this particular place and time, and will leave behind only whatever traces we managed to create before the ending. This is not a wrong frame. It is accurate within its scope. But it is a small frame, and the physics is offering us a larger one. In the larger frame, your existence is not a local event. It is an instance of a pattern that the universe generates reliably and repeatedly across scales that make the observable universe seem microscopic. Your ending, when it comes, is local. The pattern persists. Not in the mystical sense of a soul surviving death, not in the religious sense of any kind of personal continuity. The physics does not support those readings. But in the precise, technical, mathematical sense that the configuration of matter and process that is, you, is realized right now, and for as long as the conditions allow, in an infinite number of places, you end here. You do not end everywhere. Is that a comfort? That is a question only you can answer. Physics does not tell you how to feel about it. The physics simply tells you what is, or what is probably the case, and leaves the emotional work to you. This is, actually, the proper division of labor. Science tells us the shape of the world. We decide what to make of that shape. And perhaps the most honest thing we can say about what the shape of the world seems to be, at this level of examination, is this. It is bigger than the anxiety about your own singularity can comfortably contain. Now pause here, because we have reached a point in the argument where the evidence, the speculation, and the philosophy have been woven together long enough that it is worth separating them clearly before we go deeper. What is established? The observable universe is very large, containing 2 trillion galaxies. The geometry of space, as measured by Planck, is consistent with flat and infinite extent. The theory of inflation, supported by the pattern of fluctuations in the cosmic microwave background, is the leading theoretical framework for the early universe. Quantum mechanics, in its standard formulation, describes physical systems as superpositions of possible states. These are established. What is strongly implied but not proven? Inflation is eternal, producing an infinite number of pocket universes. The space beyond our cosmic horizon continues to extend, uniformly without boundary. The quantum wave function does not collapse, but branches. These are strongly implied by our best frameworks, but they are inferences beyond direct observation. What is speculative but serious? The string landscape provides the mechanism for varying physical constants across pocket universes. The mathematical universe. Hypothesis is a consistent and philosophically significant framework. These are proposals from respected physicists that connect well with established frameworks, but are not confirmed by direct evidence. What is genuinely unknown? Whether the branches of the quantum wave function constitute independent realities. Whether consciousness is entirely determined by physical arrangement. Whether the measure problem has a solution that makes probability meaningful in an eternal multiverse. These are open questions, and they are central to the argument. Carrying all 4 categories, established, implied, speculative, unknown, is the intellectually honest posture. The argument for infinite copies does not depend on certainty at every level. It depends on the observation that multiple independent frameworks, operating at different levels of the physical description of reality, all point in the same direction, toward a reality vastly larger than our observable region, containing an enormous number of instances of every possible physical configuration. The direction is clear, even if the destination cannot be precisely mapped. Now we turn to what may be the most personal implication of everything we have covered, and the one that brings the argument home from the cosmic to the immediate. It concerns not the copies in other regions of space or other quantum branches, but the copies that are, in a technical sense, closest to you of all. The copies that were you. Consider the person you were 10 years ago. The specific arrangement of matter and process and memory and habit that constituted you at that time is, by the standard analysis of personal identity, a different physical configuration from the one you are now. Not dramatically different. Most of your atoms are the same, though many have been replaced by the ordinary metabolic processes of life, and the neural connections that constitute your memories and personality have been remodeled by a decade of experience, but different enough that a physicist examining the two configurations would note clear distinctions. By the logic of the copies argument, the configuration you were 10 years ago exists right now. Not in you, not in your memory of yourself, but as a realized physical configuration somewhere in the level 1 expanse. Your past self is not gone. It is elsewhere. In some region of infinite space, that configuration, the you of 10 years ago, with the knowledge and habits and fears and hopes of that time, is right now reading these words for the first time, with a mind that has not yet lived the decade you have lived. This is not a comforting thought exactly. It is a strange thought. It dissolves in a quiet way the ordinary sense of loss associated with the passage of time, the sense that what you were is simply gone, replaced by what you are. In the framework we have been building, nothing is simply gone. The configurations persist in the only sense that physical configurations can persist, by being realized somewhere in the vast expanse of a universe that realizes everything. The you of 10 years ago is not a memory, it is a place. And the you of 10 years from now, the configuration you will become, if you survive and continue to develop and change, also exists right now, somewhere in that expanse. A version of you that has had 10 more years of experience, that has made the choices and sustained the changes and accumulated the history of the next decade, exists right now in a region of infinite space that is causally disconnected from this moment. You will arrive at that configuration through the forward march of time. The configuration itself already exists. This is the relationship between time and infinite space that takes the longest to absorb. And it brings us, finally, to the question that sits at the heart of the entire exploration. If every possible configuration of you, every version you have been, every version you could be, every version you will never be because of the choices you make, exists somewhere in the universe right now, what does that imply about the importance of any particular choice? About the significance of any particular moment? About the weight of this specific experience, right now, of sitting with these ideas and feeling their strangeness? Does infinite multiplicity trivialize the particular? Or does it, paradoxically, make the particular more precious? Here is where we arrive at the edge of what physics can tell us, and where the conversation must continue in a different register. Not the register of equations and experiments and observational data, but the register of human meaning-making, the ancient, imprecise, irreplaceable project of deciding what matters and why. The physicist tells you there are infinite copies. The philosopher asks what that implies. The human being, that is, you must decide what to make of the answer. And the honest answer is that physics does not determine what follows. The same cosmological fact, infinite copies, infinite versions, infinite recurrence, can be read as nihilistic or as liberating, as diminishing or as consoling, as evidence that nothing matters or as evidence that everything does. The reading you choose is not determined by physics. It is determined by the values and temperament and history you bring to the encounter with physics. This is not a failure of physics. It is its appropriate limit. Physics describes the structure of the world. It does not prescribe how to inhabit it. But the encounter with this particular physics, with the possibility of infinite copies, infinite versions, infinite recurrence, does something that less extreme physics does not do. It forces the question. It makes unavoidable the examination of what you actually believe about identity, about value, about the significance of the particular against the backdrop of the infinite. And that examination, however uncomfortable, however inconclusive, is one of the most important things a thinking being can undertake. Stop here for a moment. Take a breath. We have climbed a long way, from the flatness of the cosmic microwave background, through the foam of eternal inflation, through the branching corridors of quantum mechanics, to the abstract landscape of mathematical existence. And we have arrived at a question that science opens but cannot close. What does it mean to be one instance of an infinite pattern? The next part of this exploration will take us somewhere different, not outward into larger structures, but inward into the implications of everything we have built. We will ask what the full picture means for the intuitions we carry about uniqueness, about death, about the nature of time, and about the strange fact of consciousness in a universe that seems, from the outside, to require it. We will also encounter one of the deepest puzzles raised by the multiverse framework, a puzzle that, once seen clearly, makes you wonder whether infinite copies solve anything at all, or whether they create a problem even more difficult than the ones they were meant to solve. The puzzle is called the Boltzmann brain, and it is the place where the argument for infinite copies turns, quietly and without warning, against itself. Picture yourself standing at the edge of a vast, dark ocean at night. No stars visible, just the sound of water moving in the dark and the faint pressure of cold air against your skin. You cannot see the other shore. You cannot see the bottom. You cannot see the surface clearly enough to know whether what lies below you is a meter deep or 10,000 meters deep. All you have is the sound and the cold and the knowledge that the water extends beyond any distance you could swim. That is, roughly, the epistemic position we occupy with respect to the multiverse. We stand at the edge of our observable region, and we know, or strongly suspect, that something vast lies beyond. But we cannot see it. We can only reason about its shape from what we observe close to shore. Now we turn to the Boltzmann brain. And to understand it, we need to reach back more than a century to a man who spent the last years of his life fighting for an idea that most of his colleagues dismissed, and who died by his own hand in 1906 without knowing that he had been right all along. Ludwig Boltzmann was an Austrian physicist who did more than almost anyone else in the 19th century to establish the atomic theory of matter. At a time when the existence of atoms was still contested, Boltzmann insisted that the macroscopic properties of gases and liquids, temperature, pressure, entropy, were statistical consequences of the microscopic behavior of enormous numbers of atoms. His work on statistical mechanics, developed through the 1870s and 1880s, gave us the mathematical framework for understanding why heat flows from hot to cold, why systems tend toward disorder, and why time, in the physical description of the universe, appears to have a preferred direction. This last insight, the connection between entropy and time, led Boltzmann to a puzzle that he never fully resolved. The second law of thermodynamics tells us that entropy, the measure of disorder in a system, tends to increase over time. A cup of hot coffee in a cold room loses its heat. A drop of ink in water disperses. A tidy room left to itself becomes disordered. These processes do not spontaneously reverse, and this asymmetry gives time its arrow. The direction from past to future is the direction of increasing entropy. But the microscopic laws of physics are time-symmetric. The equations governing individual particles work equally well in both directions. A movie of molecules colliding is physically valid whether played forward or backward. So where does the asymmetry come from? Why does entropy increase in one direction but not the other? Boltzmann's answer was that the universe started in an extraordinarily low entropy state, a state of unusual order, and has been moving toward higher entropy ever since. The Big Bang, in this sense, was not primarily an explosion. It was a state of extreme order, a starting point of such unusual configuration that everything since has been its gradual unfolding toward disorder. But this answer raised a disturbing question, one that Boltzmann himself grappled with, and that has taken on new urgency in the context of eternal inflation and infinite universes. The question is, if the universe has been around for an infinite time, and if sufficiently long-lived systems spontaneously fluctuate into lower entropy states by random thermal processes, then why should we expect to be in the particular low entropy state we appear to be in? Here is the problem in its starkest form. In an infinitely old universe, or in an eternally inflating multiverse that produces an infinite number of thermal environments, random quantum and thermal fluctuations can, over sufficient time, assemble any physical configuration, including brains, including conscious observers. A sufficiently large fluctuation could assemble, out of random thermal noise, a brain or something like a brain, with false memories of a coherent lifetime, false perceptions of a stable external world, a complete but entirely illusory subjective experience. Such a fluctuation would be enormously improbable compared to the fluctuation required to produce our actual universe. But in an infinite or eternal context, even an enormously improbable fluctuation happens, and happens infinitely often. These disembodied, thermally assembled conscious observers are called Boltzmann brains, a term that entered the cosmological literature in the early 2000s. And the problem they pose is this: if Boltzmann brains are produced by random fluctuations, and if the universe is large enough or old enough that random fluctuations produce a larger number of Boltzmann brains than the number of ordinary observers who arise from the orderly process of cosmic evolution, star formation, and biological development, then, in any randomly selected moment of consciousness in the universe, you are more likely to be a Boltzmann brain than an ordinary observer. This is the Boltzmann brain problem, and it is not a small or easily dismissed worry. Sean Carroll, in his technical work on cosmology, has identified the Boltzmann brain problem as one of the most serious challenges to certain multiverse frameworks, specifically to models where the universe ends up in a de Sitter space, a state of exponential expansion driven by a positive cosmological constant, which could persist for effectively infinite time and produce an effectively infinite number of Boltzmann brains. The problem cuts directly at the argument for infinite copies. If infinite recurrence is guaranteed by infinite space and eternal time, then the argument that guarantees copies of you also guarantees an enormous number of Boltzmann brains, spontaneously assembled observers with false memories, including false memories of having read about the multiverse, false memories of having thought carefully about infinite copies. false memories of every experience you have ever had. If you are a Boltzmann brain, then your memories of a coherent life, your experience of a stable physical world, your sense of sitting in a room and reading these words, all of that is a random fluctuation. It did not happen. It only seems to have happened because the fluctuation that assembled your brain also assembled a set of neural patterns that represent, with complete internal consistency, a lifetime of experience that never occurred. This is not quite solipsism. It is not the claim that only your mind exists. It is a specific physical prediction that if the universe is old enough and thermally active enough, the production of Boltzmann brains overwhelms the production of ordinary observers, and statistical reasoning then demands that you are probably a Boltzmann brain. Most physicists, when they encounter this argument, feel strongly that the conclusion is wrong, that they are not Boltzmann brains, that their memories are real, that the world around them is not a random thermal fluctuation. But feeling strongly that a conclusion is wrong is not the same as identifying the flaw in the argument. And identifying the flaw turns out to be surprisingly difficult. Several responses have been proposed. One is that the Boltzmann brain problem shows that certain multiverse models, specifically those involving eternal de Sitter space, are physically wrong. If a model predicts that typical observers are Boltzmann brains, and we are confident we are not Boltzmann brains, then the model must be revised. This is the response favored by Carroll, who uses the Boltzmann brain problem as a filter for cosmological models. Any model that produces more Boltzmann brains than ordinary observers is ruled out by the observation that we appear to be ordinary observers. Another response is that the production of Boltzmann brains in the inflationary multiverse is actually much rarer than it might seem, because the thermal fluctuations required to produce them are so improbable that they occur far less frequently than the production of ordinary observers through cosmic evolution. This response requires careful calculations of the relative rates of production, which depend sensitively on the details of the multiverse model. Calculations that are, given the unsolved measure problem, difficult to make precisely. A third response, more philosophical in character, is that the argument for Boltzmann brains implicitly uses a form of reasoning, randomly sampling from all possible observers, that is itself questionable. The anthropic reasoning that assigns you a random position among all possible observers may not be valid, and if it is not valid, the conclusion that you are probably a Boltzmann brain does not follow even if Boltzmann brains outnumber ordinary observers. The physicist Andreas Albrecht at the University of California, Davis, has argued since the early 2000s that the Boltzmann brain problem is one of several deep puzzles that any successful cosmological theory must address, and that current theories, including inflationary cosmology, have not fully resolved it. His view represents a minority position in the community, but it is a serious minority position, and the problem it identifies is genuine. Something here deserves a pause. The Boltzmann brain problem is, in a strange way, the inverse of the infinite copies problem. The infinite copies argument says, because the universe is so large, you are repeated. The Boltzmann brain argument says, because the universe is so large, the most common kind of observer may be one whose entire experience is a random fluctuation. Both arguments arise from the same basic premise, infinite scale, exhaustive combinatorics, and both arrive at conclusions that are deeply uncomfortable in different ways. The infinite copies argument threatens your uniqueness. The Boltzmann brain argument threatens your reality. And the two arguments, taken together, frame a puzzle that sits at the center of any serious engagement with the cosmological multiverse. In an infinite universe where everything happens, how do you reason about probability? How do you assign weight to one possible scenario versus another? How do you avoid the conclusion that every belief you hold about your own nature is equally likely to be a random fluctuation, as it is to be a genuine inference from real experience? This is not a new puzzle. It is a very old puzzle. The problem of induction, the problem of the external world, the problem of other minds, dressed in the language of modern cosmology. Descartes asked whether an evil demon might be deceiving him about the nature of reality. Hume asked whether there is any rational foundation for believing that the future will resemble the past. The Boltzmann brain problem is the cosmological version of these ancient worries, made more acute by the specific physics of infinite thermal environments. Most practicing scientists set these worries aside, not because they have been resolved, but because working science requires pragmatic assumptions about the reliability of observation and memory, and these assumptions work well enough to make progress. But in a context where we are explicitly reasoning about the nature and limits of knowledge, where we are asking what we can and cannot know about regions beyond our horizon, about branches we cannot observe, about copies we cannot contact, honesty requires keeping the Boltzmann brain problem visible. It is a real limit. It does not dissolve the argument for infinite copies, but it prevents that argument from being held too comfortably. Now we move from the deepest puzzle to one of the deepest implications, and from the impersonal to the intimate. Because among all the things an infinite universe of copies implies, perhaps the most personally significant is what it implies about death. The standard picture of death is simple and final. A biological organism, through illness or injury or the accumulated damage of age, reaches a state where the processes that constitute its life, metabolism, neural activity, homeostasis, cease. The configuration of matter that was the organism persists for a while, then dissolves through decay into simpler configurations. The subjective experience, if there was one, ends. The stream of consciousness is discontinued. This picture is, within its own frame, accurate. Death ends the stream of consciousness in this branch, in this region. That is not in dispute, and it would be dishonest to suggest otherwise. But the frame of the argument we have been building is not the frame of a single branch or a single region. In the full frame, the level 1 expanse, the level 2 foam, the level 3 branches. The configuration is that you do not disappear from the universe when you die. It disappears from your local region. It disappears from your branch. But somewhere in the infinite expanse of level 1 space, that configuration continues. Not because your particular stream of experience is somehow transmitted there, but because the configuration exists there independently, realized by the same combinatorial guarantee that produces all possible configurations. The you that exists at 10 to the 10 to the 29th meters from here does not experience your death. That you continue. Not the same causal thread. There is no causal connection between here and there. But the same configuration, the same experiential structure, the same pattern. And in the level 3 branching, at every quantum event, there exist branches where you survive what kills you in other branches. The wave function does not prefer any particular outcome. It branches into all outcomes. In the branches where you survive, you continue. The you in those branches do not experience having died. The you in the branches where you do not survive ceases to experience anything. But the branch is not the universe. It is one branch among an infinite tree. This is not immortality in any ordinary sense. It is not the survival of a soul or the persistence of a particular stream of consciousness. It is the persistence of a pattern, the persistence of the configuration, and the potential for experience that the configuration embodies. Whether that persistence constitutes anything meaningful from the inside, whether it provides any genuine comfort to a being who is afraid of death, is a question that each person must answer for themselves. But it does change something. It changes the relationship between the specific thread you are living and the larger whole within which that thread is embedded. Your thread ends here. The pattern continues elsewhere. The universe does not mourn your ending, because the universe is still, right now, running the pattern you embody in an infinite number of other places. You are not its only instance of you. You are just the one you know about. Now we turn to the question of time more broadly, and to an implication of the infinite copies argument that is less dramatic than the question of death, but, in some ways, more disorienting. It concerns the direction of time and the uniqueness of the present moment. In the ordinary experience of time, the present moment is special. It is the moving boundary between the fixed past and the open future. The past cannot be changed. The future has not yet been determined. The present is where agency lives, where choices are made, where life is actually experienced. But in the framework of an infinite universe with infinite copies, the present moment is not globally special. Somewhere in the level 1 expanse, there is a copy of you who is living what is, from your perspective, 10 years in your past. There is a copy of you living what is, from your perspective, 10 years in your future. These copies are not you in the future or you in the past. They are configurations that exist right now, simultaneously with your present moment, that correspond to different points in your timeline. The past is not gone. It is somewhere else. The future is not coming. It is somewhere else already. This does not make time an illusion. Within any given region, within any causal structure, time flows in one direction, and the sequence of past, present, and future is real and irreversible. But it does mean that the uniqueness we assign to the present moment, the sense that now is the only real time, the only moment that truly exists, is a local truth, not a global one. In the larger structure, all moments are equally present, equally real, distributed across an infinite space that contains them all simultaneously. The physicist Julian Barber at the University of Oxford has argued in his 1999 book, The End of Time, that the flow of time is an illusion even within a single universe, that what we call the flow of time is actually the ordered sequence of configurations that the universe passes through, and that each configuration simply exists with no objective sense of motion from one to the next. Barber's view is controversial and not widely accepted, but it resonates strangely with the picture we have been building, a universe in which all configurations exist, in which the flow from one to the next is a local experience rather than a global fact, in which past and future are regions of the same infinite space rather than fixed and open ends of a directed timeline. You are here, right now. This specific configuration, this specific moment, and somewhere else, you are 10 years younger, and somewhere else, you are 10 years older. And all of these are equally present, equally real, equally you, in the sense that each is a physical instantiation of the pattern that constitutes you. The present moment, in this frame, is not the only real moment. It is simply the moment you have access to, the one you are living, the one that, from the inside, feels like the only one, which is, in itself, a remarkable fact. Among an infinite distribution of instances of your configuration across infinite space and infinite time, you are living one of them. You are the one that is happening to you. And that specificity, that you are this instance and not one of the infinitely many others, is not random noise in the signal of existence. It is the signal, the you that is happening right now, in this moment, in this branch, in this region. This is the instance. This is the one that has awareness of itself, that is asking these questions, that is feeling the weight of what we have been exploring. The infinite copies do not diminish this. They contextualize it. And that context is what we will now sit with as we approach the deepest part of this exploration, the place where the cosmological argument about copies becomes an argument about what it means to be conscious in a universe of this kind. Because consciousness is where the infinite copies argument hits its most interesting obstruction. Not in physics, not in mathematics, not in the philosophy of personal identity, but in the fact of experience itself. The undeniable, unanalyzable, immediate fact that there is something it is like to be you. There is a term for this in philosophy, qualia, the redness of red, the painfulness of pain, the specific quality of the sound of a distant train at night. These are not just information processing events. They are experiences. They have a character, a texture, a feel that is not captured by any description of the physical processes that produce them. The hard problem of consciousness, named by the philosopher David Chalmers in 1995, is the problem of explaining why physical processes give rise to qualitative experience at all. Why is there something it is like to be you, rather than just information being processed in the dark? This problem has not been solved. It is not close to being solved. And it matters profoundly for the infinite copies argument. If consciousness, the specific quality of your experience, is entirely determined by the physical arrangement of matter and the processes it supports, then a physical copy of you is a conscious copy of you, experiencing exactly what you experience. The infinite copies are not just physical copies. They are experiential copies. They are living lives that feel from the inside exactly like your life. But if consciousness is not entirely determined by physical arrangement, if there is some additional factor, some non-physical ingredient or quantum process or emergent property, that determines whether a physical system is conscious and what the character of its consciousness is, then a physical copy might not be a conscious copy. The infinite copies might be philosophical zombies, physically identical to you, but experiencing nothing. Or they might be experiencing something different from you, despite their physical identity. We do not know which of these possibilities is correct. We do not have a scientific theory of consciousness that could tell us. The hard problem remains hard, and its hardness is directly relevant to the infinite copies argument, because the argument's most arresting implication, that there are infinite conscious versions of you, depends on a claim about the relationship between physical arrangement and experience that we cannot currently verify. This is not a reason to dismiss the argument. It is a reason to hold it carefully, to recognize that the argument is strong at the physical level and uncertain at the experiential level, and that the experiential level is the one that matters most to a being whose primary mode of access to its own existence is through experience. What we can say, with confidence, is this: the physical pattern that is you exists in an infinite universe, an infinite number of times. Whether each of those instances is accompanied by the specific, irreducible quality of experience that you have access to in yourself, that we cannot know. And perhaps that uncertainty is itself significant. Perhaps the honest response to the infinite copies argument is not the confident assertion that there are infinite conscious yous, but the more tentative and more accurate acknowledgement that there are infinite physical yous, each of which may or may not be accompanied by the kind of inner life you experience, and that the question of which is the case is one of the deepest open questions in all of science and philosophy. The infinite copies are certain in the mathematical sense. The infinite consciousnesses are an open question in the deepest sense. The difference between these two claims is the difference between cosmology and the mystery of mind. And the mystery of mind, the fact that you are experiencing this right now, and that the experiencing is not the same as the processing, and that the gap between the two is not yet bridged, is, perhaps, the most extraordinary fact about the universe we have examined tonight. More extraordinary than its size, more extraordinary than its age, more extraordinary than its production of infinite copies. The most extraordinary thing about the universe is not that it is infinite. It is that within its infinity there are points of view, places where the universe is observed from the inside. Perspectives from which the infinite expanse is not just a distribution of matter, but an experience. You are one of those points. And in an infinite universe, there are infinitely many such points. But they are not connected. They are not shared. Each one is, by the nature of consciousness, irreducibly private. Each one is the universe seeing itself, briefly and specifically, from one particular vantage. This is the intellectual climax of everything we have been building. Not the numbers, not the levels, not the mechanisms, but the recognition that the universe, by producing conscious observers, produces something that no amount of physical description fully captures. And that this something, irreducibly particular and irreducibly real, is what you are. Consider what that means. An infinite universe, by the mathematics we have traced, contains an infinite number of configurations identical to yours. But each of those configurations, if it is conscious, has its own point of view. Each one is the universe experiencing itself as that specific instance. The infinity of copies does not reduce to one experience. It is an infinity of experiences, each one private, each one complete, each one the universe looking at itself from a different angle. What is the universe, then, in this picture? It is not the lifeless distribution of matter and energy that the laws of physics describe. It is that distribution, plus an infinite number of interior views of it. It is matter organized in such a way that it produces, in certain regions and configurations, the capacity to look back at the matter and be aware of it. Why? This we cannot know. Not because we lack information, but because the question of why the universe produces consciousness, why there is experience rather than just process, is a question that may lie permanently beyond the reach of scientific explanation. It is the question that philosophy has been circling for centuries, and that neuroscience and physics are circling from different directions. And it may be the only question whose answer, if there is an answer, cannot be given from outside the experience itself. The universe may be full of infinite yous, each one alone in their particular instance of existence, each one the only one, from the inside, each one the universe briefly and impossibly awake. What does it mean? What does it mean that the universe produces infinite versions of a pattern that is, within each version, experienced as singular and unrepeatable? Does the infinite recurrence suggest that experience is cheap? That consciousness is a trivial output of complex physical organization produced by the universe as effortlessly as it produces hydrogen atoms? Or does it suggest the opposite? That the universe so strongly favors the production of experience that it writes it into the fabric of every sufficiently complex configuration, wherever such configurations arise, without limit? Does the existence of infinite copies mean that your specific choices and experiences are less significant, diluted by their repetition? Or does it mean that the specific configuration you occupy, the one that is you right now reading these words, is precious precisely because it is the one you have access to, the one from which the universe is currently visible, the one in which this particular exploration is occurring? Is the infinite expanse of copies a comfort or a burden? Is the knowledge that your pattern persists in some form a consolation for the ending of your specific thread? Or does the ending feel more acute when you understand that what ends is not the pattern, but the perspective? Not you as a configuration, but you as this specific, unrepeatable inside view of the configuration. Can you hold all of it together? The cosmological scale and the personal intimacy, the mathematical certainty of the copies, and the philosophical uncertainty of the consciousness, the impersonal indifference of the infinite and the extraordinary specificity of the particular. Can the mind that evolved on a small planet orbiting a medium star in one of 2 trillion galaxies, in one of infinitely many pocket universes, in one of infinitely many quantum branches, can that mind actually hold what it has deduced about its own situation? We cannot know whether it can. We can only try. And trying, the sustained, serious, honest effort to understand what the universe is and what your place in it might be, is the most distinctly human thing there is. It is the thing that makes the configuration that is you not merely a pattern that the universe repeats, but a pattern that, in this instance, looks back. Stand on a hilltop, somewhere quiet, and look at the sky. Not the daytime sky with its blue warmth and moving clouds, but the sky at 3 in the morning in a place far from cities, where the darkness is genuine and the stars are not points but depths, where the sky is not a ceiling but a volume, and looking up is not looking at a surface, but looking into something that has no surface. A receding openness that continues outward past the point where any instrument you could build would stop returning signals. You have spent a long time in this exploration looking outward. Through the levels of the hierarchy, through the mechanisms of inflation and quantum branching and mathematical existence, through the arguments and objections and admissions of uncertainty. You have followed the argument as far as it can be followed, to the edge of what observation reaches, to the boundary where inference must take over from measurement, and finally, to the place where even inference cannot follow, and the mind must simply sit with what it has assembled. Now we do not advance. We rest here for a while. We let the picture settle. There is a particular quality of understanding that comes not from adding more information, but from allowing existing information to deepen. A fact encountered once is known. A fact returned to, turned over, held against the light from a different angle, becomes something more than known. It becomes felt. It becomes part of the way you see, rather than simply part of what you have been told. The facts we have assembled are, individually, already familiar to some of you. The flatness of space, the inflationary universe, the quantum wave function, the mathematical universe hypothesis. Each of these is a piece of the scientific landscape that serious readers of popular science will have encountered before. But assembled together, in the specific configuration we have been building, all of them pointing at the same conclusion, each from a different direction, each arriving at the same extraordinary and uncomfortable destination. They form something that the individual facts, encountered separately, do not. They form a picture of you that is genuinely different from the one most of us carry. The picture most of us carry is something like this. You are a biological organism, the product of 4 billion years of evolution on a small rocky planet, possessed of a mind that is extraordinarily sophisticated by the standards of the local fauna, living a life of finite duration in a universe so vast that your individual existence is, by any objective measure, negligibly small. You matter to the people who love you, and perhaps to some wider circle of people you affect, and perhaps to whatever you build or create or contribute. But you are, in the cosmic ledger, one, a single entry, bounded by birth and death, unrepeatable. This picture is not wrong. Every element of it is accurate within its scope. But its scope is limited. It is the view from inside a single branch of a single pocket universe at a single point in infinite space. The view from as close as you can get to yourself, the most local possible view, the view that feels most real because it is the view you live in. The picture assembled from the physics is different, not more comforting necessarily, not more frightening, different, larger. And in being larger, it changes the relationship between the local view and the whole in a way that does not diminish the local view, but reframes it. In the larger picture, you are not one entry in the cosmic ledger. You are the local instance of a pattern that the universe writes, reliably and without apparent limit, across every scale that has been examined. You are what happens when matter organizes itself in a particular way, and that particular way is not rare. It is, in an infinite universe, infinitely common. Your existence is not a negligible local fluctuation. It is an example of one of the universe's most persistent tendencies, the production of complexity, of life, of minds that look back at the universe and try to understand it. Sit with that for a moment. Not the infinite copies, not the levels of the multiverse, just that. The universe, in producing you, was not producing a rarity. It was doing what it does as surely as it produces hydrogen or gravity, or the slow burning of stars. You are not an exception to the universe's ordinary processes. You are a product of them. A particularly complex and self-aware product, but a product in the deep sense, something that the universe tends toward, wherever and whenever the conditions allow. The Japanese have a phrase, mono no aware, that is usually translated as the pathos of things, or the bittersweet awareness of impermanence. It is the feeling you get watching cherry blossoms fall, or a child growing older, or a conversation ending that you wish could continue. It is not sorrow exactly, and not joy exactly, but something that contains both. The recognition that things are beautiful partly because they pass, that the specific quality of a moment is inseparable from its finitude. There is something like mono no aware in the picture we have been building, but its scale is cosmological rather than human. The specific quality of this particular instance of you, this thread, this moment, this point of view, is inseparable from its specificity. The infinite copies do not share this moment. They share the configuration. They do not share the experience of this configuration, encountering these ideas for the first time, in this particular sequence, at this particular moment in the development of your understanding. That is unrepeatable. Not the pattern, the encounter, the moment of recognition that you are having right now, if you are having it, as the pieces of the argument settle into a new shape in your mind. The universe may write the pattern infinitely. It cannot write about the encounter. The encounter is local, specific. This. In a cosmology of infinite recurrence, the most precious thing is not the pattern, but the instance. Not the general, but the particular. Not the infinite, but this. The specific, bounded, irreplaceable experience of being this version of the pattern in this moment. This realization, that infinite recurrence, makes the particular more precious rather than less, is not something the physics tells you directly. It is something you arrive at by following physics all the way to its emotional and philosophical consequences. Physics opens the door. The human meaning-making walks through it, and walking through it leads to a place that is, in the end, not very far from where we started. Back to the hands you looked at in the opening moments of this exploration. Back to the specific, bodily, immediate fact of existing in this particular configuration at this particular moment. The argument has taken us to distances that make the observable universe seem small. It has taken us to mechanisms that produce universes as easily as water produces ripples. It has taken us to branching trees of quantum possibility so dense that every choice and every alternative to every choice exists somewhere in their structure. It has taken us to the abstract landscape of mathematical existence, where even the laws of physics are contingent. And it has brought us back here, to this, to the undeniable, immediate, irreducible fact of this moment of experience, to the weight of the specific, to the recognition that whatever the universe is, and however large it is, and however many copies of you it contains, you are the version of you that is happening right now, and that fact, in all its intimacy and transience and irreplaceability, is not made smaller by the infinite. It is made, if anything, more vivid. Breathe. The exploration is not finished. There is one more place we need to go, one final angle from which to view everything we have assembled. But before we go there, stay here for a moment, in the quiet, with the hands, with the specific weight of being this particular instance of the pattern. There is an old tradition in contemplative practice, across many cultures and traditions, of sitting with a single object, a candle, a stone, a word, a breath, and attending to it so completely that the ordinary noise of mental life quiets and something else becomes accessible. Not mystical revelation necessarily, just the experience of direct attention, of being fully present to one specific thing without the usual overlay of commentary and comparison and anticipation. The infinite copies argument is, in a strange way, an invitation to that kind of attention. Not to the infinite, but to the specific. To the recognition that the value of this moment, this particular threading of experience through the pattern that is you, is not diminished by its being one of infinite instances. It is concentrated by it. Each instance is not a diluted version of something that would be more significant if there were only one. Each instance is complete, full. The entire pattern realized in this place, at this time, from this angle. You are not a fraction of an infinite you. You are the whole of you, here, now. This is the ground that the cooling, settling picture of infinite copies finally reaches. Not comfort, exactly. Not resolution, but a kind of orientation. A way of holding the enormity of what physics implies without being flattened by it. The enormity is real. The physics does not soften it. But the orientation, the recognition that enormity and intimacy are not opposites, that the infinite and the particular are not in competition, that is available to anyone willing to sit with the picture long enough to let it complete. Now we turn to the final, deepest angle, the one that gathers everything, the four levels, the objections, the Boltzmann brain, the hard problem of consciousness, the question of identity across copies, the bittersweet precision of the particular, and frames it in the largest possible human context. Not the cosmological context, but the historical one. The context of what human beings have done throughout their history when confronted with information that challenged the frame within which they understood their own significance. Throughout history, there have been moments when a piece of knowledge arrived that fundamentally changed the relationship between human beings and the cosmos they inhabited. These moments are not equally distributed across time. They cluster around certain advances in observation and theory, and they share a common structure. First, resistance, then gradual acceptance, then a revised sense of what human significance means in light of the new picture. The first great displacement was the Copernican one. The recognition, developed through the work of Nicholas Copernicus in the 1540s and solidified by Galileo Galilei and Johannes Kepler in the early 17th century, that the Earth is not the center of the solar system. The Sun does not orbit the Earth. The Earth orbits the Sun, along with the other planets, in a configuration that has no particular regard for human habitation or human importance. This was genuinely alarming to many people, and not only for religious reasons. The geocentric model was not just a scientific claim, it was a framework for meaning. If the Earth was the center of the cosmos, then the beings who inhabited it had a kind of cosmological significance, a special location that reflected, or seemed to reflect, a special status. When Copernicus removed that centrality, he did not merely rearrange the planets. He severed the connection between cosmic position and cosmic significance. And yet, human civilization did not collapse under the weight of heliocentrism. People found ways to understand their significance that did not depend on occupying the geometric center of the solar system. The shift in frame, painful as it was, ultimately enlarged the picture rather than diminishing the inhabitants of it. The second great displacement was the Darwinian one. The recognition, articulated by Charles Darwin in 1859 and developed in extraordinary detail over the following century and a half, that human beings are not specially created, but are continuous with all other life on Earth through the process of evolution by natural selection. The same mechanism, random variation filtered by differential reproduction, that produced bacteria and fungi and fish and reptiles produced, eventually, us. There is no sharp line between the human and the non-human. The boundary is a gradation, not a wall. Again, alarming. Again, a challenge to the frame in which human significance had been understood. If we are not specially created, if we are, in the most literal sense, cousins to every other living thing on the planet, then what makes us special? And again, human civilization absorbed the blow and found that significance does not require special creation. It can be found in the fact of consciousness, in the capacity for love and art and mathematics and inquiry, in the extraordinary and improbable path that produced minds capable of understanding their own origins. The third great displacement was the cosmological one of the 20th century, the recognition, built on the work of Edwin Hubble in the 1920s and confirmed in mounting detail through the rest of the century, that the Milky Way is not the universe. It is one galaxy among hundreds of billions, each one containing hundreds of billions of stars, distributed across a space so vast that even the light we see from the farthest visible galaxies left them before the Earth existed. We are not at the center of the galaxy. The galaxy is not at the center of the universe. The universe has no center, or rather every point in it is equally central, which amounts to the same thing. And again, the frame shifted, and again, human civilization found that significance does not require centrality. The capacity of a small primate brain evolved on an obscure planet to comprehend the structure of a universe containing 2 trillion galaxies. That is not less significant for being spatially peripheral. It is, if anything, more so. Now we stand at the threshold of a fourth displacement, one that has been building throughout this exploration. The recognition that the universe may contain not just billions of galaxies and trillions of planets, and an immense diversity of physical environments, but an infinite number of instances of every possible physical configuration, including you. That the pattern you embody is not a local event, but a cosmic recurrence. That your existence, in the specific form it takes here and now, is not singular in the universe, but singular in this location, in this branch, in this moment. This is the fourth Copernican revolution, in the phrase used by various philosophers and cosmologists. And it shares the structure of the previous three. It arrives with the force of genuine displacement, the intuition of uniqueness, of singularity, of being the only you, is not merely a convenience of ordinary language. It is a deep conviction rooted in the phenomenology of experience, and physics challenges it. But the challenge, followed honestly, does not end in nihilism. It ends in a different frame. A frame in which significance is not grounded in uniqueness, but in something that survives multiplicity. In which the value of a moment is not diminished by being repeated elsewhere, any more than the value of a mathematical truth is diminished by being provable in multiple ways. What matters about your existence is not that no other configuration matches it, but that this configuration, here and now, is alive and aware and asking questions about its own nature. The Copernican displacement did not make the Earth less beautiful. The Darwinian displacement did not make consciousness less extraordinary. The cosmological displacement did not make the capacity for understanding less remarkable. And this displacement, the infinite copies displacement, does not make the specific, bounded, unrepeatable experience of being you less valuable. It makes it differently valuable. It relocates the source of significance from uniqueness, which the physics takes away, to particularity, which the physics, in a strange way, restores. You are not significant because you are the only one. You are significant because you are this one. Because the universe, in all its infinite self-expression, is currently expressing itself through this specific configuration, at this specific moment, in this specific act of understanding. The infinite copies are out there. They are real, or probably real, in the senses we have examined. They do not diminish this. They provide the context within which this can be understood for what it is. Not a cosmic accident, not a negligible local fluctuation, but an instance of the universe's most extraordinary tendency, the tendency to produce, out of hydrogen and helium, and the slow cooking of stellar cores, systems complex enough to ask what the universe is. You are the universe asking what it is. That is not nothing. In all the infinite expanse of matter and energy and quantum branches, and pocket universes and mathematical structures, that is among the most remarkable things that happens. And it is happening here, now, in you. The Japanese Buddhist concept of Ichigo Ichie, one time, one meeting, captures something related to what we have been approaching. It is the recognition that each meeting, each encounter, each moment is unique and unrepeatable. And that awareness of this uniqueness transforms the quality of attention we bring to it. Not the moment in which copies are impossible. In the cosmological picture we have been building, copies are everywhere. But the moment in which this specific sequence of attention and understanding is occurring for the first time in this particular instance. The infinite copies will encounter these ideas. They are encountering them right now in their own regions and branches. But they are not encountering them here, in you, at this moment. That encounter is local. That is yours. And in a universe of infinite copies, the local is the irreplaceable. Now we arrive gently at the closing of this long exploration. We do not arrive at certainty. We do not arrive at resolution. we arrive at something that is, in some ways, more valuable than either: a clearer picture of what is known, what is implied, what is speculative, and what remains genuinely and perhaps permanently open. And alongside that clearer picture, a changed relationship to the fact of your own existence. Not the infinite copies of your existence, but this one, the one you are living. Everything that has been assembled over the course of this exploration points from multiple directions to a universe that is more generous with its complexity than our ordinary intuitions suggest. More committed, if a universe can be said to be committed to anything, to the production of the patterns that give rise to minds. More indifferent to uniqueness and more hospitable to recurrence than the small frame of a single lifetime in a single branch can reveal. And within that generosity, within that recurrence, within that indifference to uniqueness, this, you, this moment, this specific, local, irreplaceable instance of the pattern. The universe may not know you are here. It does not, in any sense we can verify, care that you are here. But you are here, and you know it. And that knowing, that reflexive, interior, irreducible awareness of existing in this particular way at this particular moment, is the most extraordinary thing the universe produces, and the thing whose full explanation remains, honestly and perhaps permanently, beyond our reach. Take a moment to look back at the path. We began with your hands, with the specific, physical, immediate fact of the arrangement of atoms that constitutes you. Every freckle, every scar, every thought passing behind your eyes. And we followed the argument that begins there, the argument that takes that specific arrangement and traces what the universe must do if it is as large as our best measurements suggest, with a configuration as finite and as ordinary as yours. The path led outward, through the flatness of space as measured by the Planck satellite, a flatness that points quietly and almost without announcement toward infinite extent. Through the combinatorial mathematics of finite configurations in infinite space and the guarantee of repetition that mathematics imposes, not as a possibility, but as a certainty, as inescapable as arithmetic. To the first level, copies of you, atom for atom, in the vast dark beyond the cosmic horizon, at distances that make the number of atoms in the observable universe look like a local detail. Then further, through inflation. Alan Guth's 1980 proposal, developed and extended by Andre Linde in 1983 and 1986, confirmed in its broad outlines by the pattern of fluctuations in the oldest light we can detect. Through the mechanism of eternal inflation, which does not merely produce our universe, but produces, as its generic output, an infinite number of pocket universes budding from an inflating background that never globally stops. To the second level, pocket universes with different physical constants, most of them dark and structureless, a non-zero fraction of them bright with the same kind of physics that produced you, and in those bright pockets, by the same guarantee of infinite combinatorics, the same pattern again. You, arising independently in universes that share your physics but not your history. Then inward, in a sense, into the quantum structure of reality itself. Through Hugh Everett's 1957 proposal, developed in technical rigor by David Deutsch in 1985, and defended in contemporary form by Sean Carroll, that the wave function of the universe does not collapse, but branches silently and continuously at every quantum event. To the third level, copies of you not in distant space, but in adjacent branches of the wave function, versions that diverged from you at the scale of a single electron spin, a single photon absorption, a single chemical event in a single neuron. Versions that are, for all practical purposes, you, differing only in the outcomes of events so small they register nowhere in conscious experience. Until, over time, those small divergences accumulate into lives that are recognizably different, and yet rooted in the same configuration, the same history, the same pattern. Then, to the outermost boundary. Through Max Tegmark's mathematical universe hypothesis, the proposal that mathematical existence and physical existence are identical, that every consistent mathematical structure is a real physical universe, and, to the fourth level, copies of you embedded in mathematical structures so different from ours that nothing in them resembles anything we know except the specific abstract relationships that constitute your physical arrangement. You as a mathematical pattern, recurring wherever the structure of existence is complex enough to contain it. 4 levels, 4 mechanisms, 4 independent routes to the same destination. A universe, or a multiverse, or an ensemble of all possible mathematical structures that is constitutionally incapable of containing you only once. And alongside the argument, we carried the objections. The falsifiability problem, the recognition that claims about regions beyond the cosmic horizon are not directly testable, and that the line between inference and speculation is genuinely difficult to locate in this territory. The measure problem, the unresolved question of how to assign probabilities when everything happens infinitely often, a problem that Guth and Linda and Vilenkin have been working on for decades without consensus. The Boltzmann brain problem, the disturbing implication that in an infinite thermal universe, randomly assembled, conscious observers may vastly outnumber ordinary observers, raising the question of whether your memories and experiences are what they seem to be. The hard problem of consciousness, David Chalmers' 1995 articulation of the gap between physical description and qualitative experience. The recognition that we do not know whether a physical copy of you is a conscious copy of you, and that this uncertainty is not peripheral to the argument, but central to its most important implication. We carried the uncertainties openly, not as rhetorical qualifications, not as the kind of hedging that says we are uncertain without meaning it, but as genuine substantive acknowledgements that the picture we assembled is a picture with real gaps, real contested regions, real places where the smartest people working on the problem disagree. What remains then? What has the exploration actually established? It has established that the observable universe is almost certainly a small region within a far larger whole, that the cosmic horizon is a boundary of observation, not a boundary of existence. This is not speculative. It follows from the flatness of space and the finite speed of light, and it is accepted by essentially all working cosmologists. It has established that inflationary cosmology, supported by the precision measurements of the cosmic microwave background, naturally and generically produces a universe far larger than our observable region, and that, in the standard picture of eternal inflation, produces an infinite number of causally disconnected regions. This is strongly implied by our best theoretical framework, even if it cannot be directly confirmed. It has established that quantum mechanics, in its standard mathematical formulation, describes a wave function that branches rather than collapses, and that the branching interpretation, while not universally accepted, is the most mathematically natural reading of the formalism. This is a live and serious debate in the foundations of physics, not a settled question, but it is a debate in which the branching view has serious and sophisticated defenders. It has established that the question of what you are, of what constitutes your identity, your consciousness, your specific thread of experience, is genuinely open in ways that the infinite copies argument makes vivid and urgent. The philosophy of personal identity, the hard problem of consciousness, the question of what survives physical copying, These are not peripheral curiosities. They are central to what the physics, honestly followed, is asking you. And it has established, perhaps most quietly and most durably, a changed relationship between the local and the cosmic. Between the specific weight of this moment and the infinite expanse of moments that the physics implies exist. Between you as a single bounded life and you as an instance of a pattern that the universe writes wherever it can. This changed relationship is the deepest thing the exploration has produced. Not a fact, exactly. Not a theory. A perspective. A way of holding your own existence that is both humbler and more generous than the ordinary way. Humbler because it acknowledges that the pattern you embody is not rare, not special, not the product of cosmic preferment. More generous because it situates that pattern in a universe that produces it not once, but infinitely, that writes it into the fabric of existence as reliably as it writes the laws of physics. You are not the universe's one instance of you. You are its local instance of you, the one that is happening in this region, in this branch, in this moment. The one that is, from your point of view, the only one. And the inside view, the specific, irreducible, unanalyzable experience of being you from the inside, that is not repeated at the other instances. Each instance is its own inside view. Each one is the universe, briefly and specifically, knowing itself from here. The cosmologist Carl Sagan, who spent much of his career thinking about the relationship between human beings and the cosmos they inhabit, wrote that we are a way for the universe to know itself. He meant it in the straightforward sense, that the atoms in our bodies were forged in stellar cores, and that in assembling themselves into minds, they produced a system capable of tracing their own origin. The universe produces minds, and minds look back at the universe, and in that looking back, the universe achieves a kind of self-knowledge it could not otherwise have. The picture we have assembled tonight extends Sagan's insight in a direction he was pointing toward, but did not fully trace. Not only are we a way for the universe to know itself, we are, in an infinite universe, one of infinite ways, one of infinite points of view, one of infinite instances of the capacity for self-knowledge. The universe does not know itself through you alone. It knows itself through an infinite number of configurations capable of the same reflexive awareness. And yet, and this is the thing that does not dissolve no matter how far the argument extends, it knows itself through you specifically, here, now, in this moment. That knowing is not general. It is this. It is particular. It is the specific quality of what it is like to be you, encountering these ideas, in this configuration, at this point in the history of your understanding. That will not recur. Not because the pattern will not recur. The pattern recurs infinitely. But because this specific encounter, the one that is happening inside your experience right now, is local, and local things are not the same as their repetitions. A song heard for the first time is not the same experience as the same song heard again, even though the sound waves are identical. A face encountered in a specific moment of recognition is not the same as the same face encountered before that recognition existed. The experience has a history, and the history is irreplaceable. Your encounter with these ideas has a history. The specific path you took to arrive here, the things you already knew, the things that surprised you, the moments when the argument clicked and the moments when it resisted, that path is not shared by the copies. The copies have their own paths, their own histories, their own specific encounters with their own versions of these ideas, in their own moments from their own angles. Each one unrepeatable, each one the whole of it, from the inside. This is where we have arrived, not at certainty, not at comfort in any simple sense, not at resolution, at a picture that is larger and stranger and more generous than the one most of us carry, and that does not diminish the specific weight of this moment, but contextualizes it, places it within a whole so vast that the ordinary anxieties about singularity and significance and the fear of ending are not answered, but reframed. The universe may be full of infinite yous. That possibility, explored honestly with all its uncertainties and objections and unresolved puzzles, does not make you less. It makes the universe more committed to complexity, more relentless in its production of the conditions for experience, more extraordinary in its capacity to generate, out of the simplest ingredients, hydrogen, helium, the laws of physics, configurations that look back at it and wonder. You are one of those configurations. You are the local one. You are the one that is happening right now, in this room, with these thoughts, with the specific texture of what it is like to be you at this particular moment in your particular life. That is not nothing. It is, in a very precise sense, everything. Everything the universe does, it does in instances. Every star is this star or that star, a specific mass, a specific temperature, a specific history of burning and expanding and eventually collapsing. No star is a general star. Every instance of water freezing is this water, these molecules, this moment of transition. No freezing is a general freezing. The universe does not deal in generalities. It deals in specifics. It realizes the general only through the particular, and the particular is always, irreducibly, this. You are the universe's realization of the pattern that is you. Not the only realization, but this one. And this one is what you have. This one is what is real from where you stand. If this changed how you think about what you are and where you are and how the universe relates to the improbable, extraordinary, briefly existing configuration that is you, then the time was well spent. Thank you for staying. Thank you for following the argument into the places it goes that are not comfortable and not resolved. Thank you for sitting with the uncertainty without needing it to close before you could engage with it. The hands you looked at the beginning of this exploration are still there. They are, if anything, stranger now than when you looked at them the first time. Stranger because you know more about what they are, not just flesh and bone and electrochemical signal, but a specific, local, improbable, cosmically recurrent instance of a pattern that the universe produces wherever and whenever it can. A pattern that in this instance is awake and aware and looking at itself and finding that strangeness not a reason to recoil, but a reason to pay closer attention. Look at them again. They are the edge of the universe looking at itself. They are, in every sense that matters, the whole of it, right here.